Hello. Good evening. Welcome to the stream. I got my coffee, and I think actually I posted the links to the stream everywhere. Yeah. I am starting a bit late, and it's 10:30 here, and I have coffee, so I'm probably not gonna fall asleep until like 3 a.m. But this stream is not going to be that long, hopefully. Yeah. So, let's see, just a moment. I need to think. Let me prepare some stuff. And then we'll begin. Oh, the garbage truck is out there, so it's the perfect time to start the stream when the garbage truck comes. And they're always right on time at 10:30. Can I... I was wondering if I should... Nah. Next time. Oh yeah, the lighting is terrible. Okay, some other time when I get better lighting. Okay, so yeah, I was just wondering if I should have a video as well, but then I'll be very aware of it, so maybe not. Okay, let's see. I think I'm gonna start in a minute. Monty, there it is. And then I also want to have my project files open. Okay, I think I'm ready. So, let's begin. Okay. Is it actually full screen? Yes, it is. So, hello everyone again to the stream. We did the stream 2 days ago. And on the last stream, I showed the baked vertex maps. and on the that was before the last stream. But then I showed the new car light. I actually did the new car lighting with raycasts. And then I made I made a separate car shader which could accept the lighting, the shade from the raycasts, and implement Bananov's suggestions of raycasting into the sun. Yeah, that's it. So yes, I was raycasting towards the sun, and depending on how many raycasts hit, that's how much I if they hit a mountain or anything, it casts it means that the car should be shadowed, so I send a darker color to the car. And that was what I did in the last time. And now on this one, this is what I'm planning to do. These are some ideas for future streams. I'm gonna push them back. So for this stream, let's see. So yes, there have been some updates in these 2 days. So the first one, let me actually start the game. There we go. A new thing I was actually making today was an improved scene and asset inspector. So what I did is this is my engine's UI. So I have 2 UIs right now, and where is the other one? Oh, it's hidden here. So these are all the parameters for this particular game, for the rally game. So I have some car data here that I can edit on the fly. Torque tables, slip tables, and stuff like that. Some rendering things. I can debug sun rays. Yes, this is exactly what I did on the last stream. So yes, these are the rays that get occluded by the sun, by the mountains. So even if you go around the bridge, like when you pass through these pillars, they occlude the car and it becomes black or dark. Let me just remove the frame buffer so you can see it. It can be either partially dark or fully dark, depending how many rays hit. And right now I'm using 20 rays, so 20 rays every frame. I did try it with 500 frames, and it was yeah. I mean, there was no CPU slowdowns or anything, I felt, but it was just ridiculous. Like, why would you have 500 rays? This is about a good number, I think. I didn't profile it yet, so I don't know exactly what's the impact. But yeah, you can see here that the car shadow is also changing, and the color of it is going up and down here, as you can see it. It's totally dark, and now it's going up. So yes, you can see it live, the car shadow color changing. So this is the UI of the game itself, of this rally game. Oh yeah, and you can also this camera, if you go up, you can flip the camera around, which is not... I should definitely clamp the angle. Yeah, that's actually already on the to-do list. So the drive, that's less important now. What's more important now is that I added this... Yeah, it is kind of annoying when you're moving your mouse. And I also need to lock the mouse. Wait, let me add it to my to-do. Maybe I can do that today, actually. Lock the mouse. Oh, not since last time. This is lock the mouse. And only move on right click or something. something. Okay. Whoops. So yeah. Anyway, what was I talking about? Yeah. So yeah, let's use this camera for messing with the UI. Hello, Black Bladder. But if you're going fast, a quick flip might be okay. You mean this flip? You can see the, I don't know. It's almost like, you know, some games have like a look behind, to look behind for your opponents. Yeah, let's move to this. So yeah, basically I have a scene inspector. So the way my engine works is you have game objects, which are, the game objects are actually initially I called them models because they're not really real game objects, but then I decided to use the word game object anyway. So if you like, you know, like in game engines like Unity, there's a game object and it like has these components and stuff. And yeah, it's quite complex actually. But my game objects, they're only two things. They only actually have two parameters. Actually, I added... No, there's more parameters. Okay, let's see. Because I just remember there's a transform as well. So yeah, it is a very light kind of class. Game object. So, this is my game object. This is everything. So basically what it does is it has a transform. The transform tells where, it's a matrix. So it tells you where the position, rotation, and scale is. You probably know from the audio is annoying. Hello, Maxiator. You could also add a super low poly character driving the car while the camera is in third person. Yeah, I was thinking actually about that because right now there is. I was thinking about it today that I might actually just put opaque windows that are not transparent because for two reasons. First, I can't render semi-transparent objects yet. But yeah, I'm probably gonna fix that in the next version or something. Oh, and by the way, if I'm gonna tell you a secret. The wheels actually don't rotate. They never did. I just never show them up close. But yeah, even if I run at fast, you can see that they're not rotating. They do rotate when I steer, right? But they don't they don't roll. So actually, when you see it from far away, you don't even see it, you know. And especially, you know, on the stream or in the Twitter videos, you can't even see them. Yeah, it's like one of those things that I just need to complete to make it work. So yeah, I mean, I already have rotation of the wheels like sideways. So why don't I have rotation of the wheels like rolling? I don't remember, but it was just like, it was one of those things that was just like, it's not a priority, so let's not care about it yet. But yeah, I think I have it in my to-do as well. Wheels spinning in the air. Add crash sounds. I don't make wheels roll. Yeah. Hello, Loms. You don't move the texture UVs. I could move the texture UVs, yeah. But yeah, you know, like how old games, the way, because before motion blur existed as an image effect, old games would have multiple textures of wheels with blur on them. So they would like switch between the blurred textures, you know, to make it look like they're going really fast, like, you know, blurring. Which actually was a really good, really nice effect, and I'm probably going to add that as well. But maybe not in the first version. I don't know, because this is really like more like a finishing touch thing. Uh, so yes, your question uh, about character driving. So yes, I was thinking about having an opaque window because for two reasons, which I now completely forgot. So first one is transparency, right? I can't do semi-transparency, and the second is that there's no driver. So like if you just put opaque window, it's like, you know, okay, the driver is in there. But if you can do this and you can see inside, then I need to have some kind of a driver. But the problem is that I don't have skinned meshes in my engine yet, and that's kind of a difficult thing to do. So I mean, it's not that difficult. I just need to implement it, right? I already talked about it on my previous streams. But yeah, I mean, I wouldn't if I did add a driver, its hands would be static, like they wouldn't move. It was just like it would be just like a dummy, a static dummy. So yeah, I have some character models I used before, so I could just put one. And yeah, I one of the things was I think I added somewhere. Yeah, I said for V1 maybe because it's not essential. I did add bobbing heads, which I thought like I could put a head like a helmet inside a car and then just make it move with physics or something. You know, just like going forward and leftwards, you know, just bobbing, and it would look maybe fine. I did something similar with in Infinland actually, but in Infinland because it's Unity, I did have skin meshes and I could move bones and stuff. Anyway, yes, that was the answer to your question. And where was I? Also, okay, let's see. Rotating texture or rotating mesh? Well, yes, they would do both. I mean, if we're talking about the old games, they would also rotate the mesh, but then they would swap textures between like multiple blurred stages, right? Maybe you can even find online like racing game wheel texture. Wheel texture blurred. There must be a radial blur shader. Okay, somebody made the shader that actually blurs. That's actually nice. But yeah, here I think this is an example of a... Oh yeah, this is definitely that exact thing. And this is from Studio 397, so this is rFactor 2, I think. So in rFactor 2, they still use this technique where they have like multiple textures, and as you can see, and then they have the blurred version, which they then swap. So yeah, that's how they used to do it before, but also why not use it today, you know, because the only problem is that back in the day, wheel meshes were really simple. Like it was just an opaque object, just like mine, right? There's no holes in it. It's actually quite pixelated. Let me remove the sun rays. So yeah, they were opaque actually. They didn't have holes. But in newer games, right, they're so detailed, they're so well like they're so high poly and have holes in them. So what do you do when you have a hole inside a wheel? You can't do blurred textures that well. An option is to have a semi-transparent object, right? That will then you will be able to look through the wheel. But then, you know, the modern engines, they hate transparency. So whenever you have transparency, that probably means that you can't have a depth map on it. So none of the ambient occlusion effects and stuff like that won't be applied to transparent objects. So it's always a compromise with graphics. You invent one thing and then you fuck up everything that's been done before. But yeah, I do like the aesthetic of just using blurred textures. I think it's very old school. Don't rally cars have a driver and a map reader? It's two models then. Exactly. Exactly, yeah. I will definitely have to have two heads bobbing. I guess it's now a shader material that will have a blur effect that you can put as a slider when the speed is blurring the image from... Yeah, I mean, that would be a nice solution as well, to make it in a shader. But then, how do you actually make it in a shader? You would need to have some kind of an anisotropic blur. Also, is this a custom engine made by you or something else? Yes, this is a custom engine. So I made this from scratch since like 2 years ago, but I haven't been working on it full time, because I have other projects and work stuff as well. But yeah, it is OpenGL using like GLFW, GLM, and other stuff. And also Bullet for physics. So it's not like I made everything, right? But I had to connect everything together. I am actually using quite a lot of libraries. So Tracy for profiling, Tiny GLTF for loading meshes, STB image for loading to textures, ImGUI for GUI. There's a lot of things. So external dependencies. No, this is Microsoft stuff. But yeah, it's pretty much here. So there's no editor. I just place everything by hand. I hard code everything. Like this is the main code of the game of the rally game. So this is pretty much all the engine classes, and then this is the main file for the game. So I basically do everything in a sequence. This is where I do transmission stuff, and this is input, for example. And this is where the frame actually begins. So while the engine is running, do everything, do all this stuff, and then just end when it's not running anymore. And then, yeah, I don't know. These are, for example, gear ratios. I just have them here. Scene uniforms. This is for passing to the shader. It's for fog, for example, fog radius and stuff. Sounds, gravel sounds, which I should actually replace. Or actually, I should add the tarmac sounds. It's in the to-do. Loading each like audio clip separately and stuff like that. So basically, this is the whole game is just like very, very direct. Everything is like, yeah. So anyway, yeah, here's where I load meshes using a GLTF. So, hello Farfade, nice to see you again. So what was I talking? I was talking about the scene and asset inspector, which I shut down the game. I didn't even show. Where is the chamois? It's in the art. Here it is. Where is it? Wait. Oh, there it is. Crowds and chamois. I put crowds and chamois as in the same category because it's billboards. But you ask where it is. Here it is. Oh, sorry. The engine is running. Here it is. The texture is still here, the one I found. So I'm gonna turn this into a sprite and put it in various places for you to find. Yes, so anyway. The Drive UI. So this is what I added today. So the scene... Oh yeah, I was talking about the game object. I wanted to explain that actually. The game object... Okay, let me actually shut down because I don't need to debug. This is the whole game object. So what it does is it basically binds a mesh to a material, and a material is just a set of properties which are then assigned to the shader, right? So the material is like a shader combined with properties. And then you have a mesh. And then, well, I actually have this game object parent, but I'm not actually using it yet because I don't have a graph structure or anything. All of the objects are actually just linear array. There's no parenting yet. So I don't know actually why I have this. I think I can actually even discard it. And then you have the transform, which is like position, rotation, and scale, right? And the bounds of the object so that the renderer knows when to cull the objects, right? When to not draw them. Like when you're looking away and the camera is, the bounds of the mesh are not, the bounds of the game objects are not inside, are not visible, then don't render the mesh, right? So if you're looking in front, if your mesh is behind, don't render it, which is called frustum culling. Yes, so this is like a game object. It's super simple. It doesn't have any components. I don't have components. The way the game works is you literally just have to point directly into objects and move them around or assign physics to them or stuff like that. So yeah, and so if you look into the game, which I'm going to start again, and so yeah, this is the scene is just a collection of objects, of game object. So if you open this cube, you can see, which I have no idea, I think cubes are actually houses, I just didn't rename them. But let's go to, for example, the car, right? The car has a position, this is the transform, so it will show, well, this is funny because I can move the position, but the physics actually doesn't change because the physics is constantly moving the car object to the rigid body of the car. But the camera is being calculated somewhere in between. So the camera actually thinks that the car is moving, but it's not. So it's trying to follow the object, but there's nothing to follow actually. So it's constantly like trying to find it, but the physics is then taking the game object back and putting it on the rigid body. So yeah, I can't actually change the position. But for some other things like Monty Road, this is the road I am on. Yeah, and I added this render check mark today so that you can pick what to render and what not. So let's find something. Yeah, this is the wall. Oh, this is the, yeah, for example, oh, this is part of the road, as you can see, because there's two objects, one on top. And it's quite useful to actually debug with this. So, but the thing is that because this is a static mesh, nothing is moving this, I can actually move it by hand. So this is kind of like an editor, but it's not really an editor. But yeah, this actually doesn't change anything because the physics, the static meshes, the static colliders are actually kind of baked. They have nothing to do with the graphical objects at all. So the graphical objects can move and then nothing happens. But yeah, it's quite useful to actually be able to like remove stuff. Like I can remove the car. I can say don't render the car. I see only the wheels then, which is funny. But yeah, so that's nice. And then I also have, that's the scene. So the scene is everything you see in the scene, right? In this world. But then I also have assets, which is kind of the memory that is loaded and pushed to the GPU. So this includes meshes, shaders, materials, and textures. So if you go into the textures, I can now analyze which texture is loaded and see it, and this one is actually not used at all. This is for an old, it's big, for an old dirt road I had. So for example, because I don't need this texture, I'm still loading it, so it's kind of useless. Yeah, one of the things that I actually want to add into this inspector is to show to me which one is unused and which one is not, so that I can remove it from my assets. Oh, this is the rocks, the one that is applied to those rocks in behind. And here is the wall next to the road, and then I have the road with the pavement and the curbs and stuff like that. And for materials, yeah, so materials are binding shaders, which is this one. It says that it loaded a standard shader. Oh, the car is climbing onto top of the hill. Wow, I need to fix this. I need to make this not realistic. I need to make this more realistic, I mean. This is totally unrealistic. Okay. But the cool thing is you can inspect all the textures that are bound. So, well, I can see that the light map is actually bound to all the textures, as you can see, to this one and to this one. But I'm not using the light map anymore, so actually I should remove it. I don't need to have a light map anymore. So this is something I remove light map texture. I should remember to do that later. And this one is a blob. So this blob from the car shadow is actually set to each shader, to each material, and it gets applied to all shaders. So yeah, that's pretty much it. And then for shaders, yeah, I have this recompile button, but it actually doesn't work. I would love to be able to live recompile shaders while I'm like writing them and then recompile them, but that's for some other time, maybe not for the first version of the game. And I mean, anyway, this is just my own development feature, not a thing that users should use, but maybe they would like to edit shaders as well. I have some drop in the stream. I'm the only one. Oh, is there a drop? Maybe it's because of the game I'm running. I don't know. The blob texture is baked from the car. It's just drawn by hand. I'm not actually sure. I don't remember because I had this blob for a long time, I think. I think I actually rendered it in Blender. But you know that you can actually generate one really fast. Okay, let's do this because it's kind of fun. Let's try to do it. Oh, what are the other things I did? Optional rendering. I showed that you can turn off rendering now of specific objects. Input with if key down. Yes, I'm gonna talk about this after this. You could. I mean, let's not do it for the game, but I'm gonna show you some of the things. So yeah, here's my beautiful car model with the texture as well. It doesn't have a wheel because it's somewhere. What is this? Oh no. Oh, right. Wait, this is not the correct collection. Is it? This is the one. This is the one for the export. Yeah, because this one also features a hull. So this object here is a convex hull. So this is the one I use for collisions. And the reason why I'm using that one and not just creating a convex hull out of the mesh, out of the car mesh, is because I want to have some margin below. So I don't want the very bottom to collide with the ground, right? I want to have some distance because in real life, in real cars, the very bottom of the car is actually flexible. There's like a little rubber strip. So actually they don't. Oh, there's garbage truck again. What the hell? So many garbage truck going on around all the time. Have you experimented with Twitch integration? Other cars or chat people? Other cars? I don't understand. What do you mean? other cars. That would be funny. So yeah, anyway, yes, the hull. So yeah, I used the hull, but so there is a wheel. It's over there. There's only one wheel, but let's try. Let's for this test just make 4 wheels. I think the dimensions are incorrect, to be honest. So what you can do. Oh, I actually have a window as well, which doesn't use the correct texture. I totally forgot I have windows, but I'm not actually exporting them. So yeah, if you create a plane and put it below, so this is going to be our blob texture basically, right? And then you put it a bit under the car, just so that the wheels don't intersect it. And well, these wheels are it doesn't matter really. And you could basically use a yeah, if I use cycles and I render with cycles, let's see what happens. So yeah, you can see that it darkens, but there's no sun. So let's add a sun. Okay, so here is a very, very hard shadow. It's completely vertical and with a very hard shadow. So let's add instead you can have chat people be the other cars on the track as bots. That would be crazy. But yeah, it would take too much to implement, I think. So yeah, if you have like the sun, but the shadow is too sharp, you can increase the angle of the sun so that it's softer. And now we have something that is more sharp. More less sharp, that's what I meant. And then strength. Yeah, let's make it so it's white. At least white. Okay. So something like this. There you go. And now what we can do is we can make a new texture. Let's make it quite small, and let's say blob. And assign this texture. Okay, but actually what I need to do is I need to not assign the texture, just have white, and then when you select it and go to bake, let's see, bake combined, without these, only the diffuse. Let's see how it goes. So there it is. There's our blob. So as you can see, quite easy to make one. But if I remember correctly, I actually made maybe I made that one in by hand. I can't remember. Let's see. Where's my blob? Where did I put the blob? I can't remember. Smoke. That's smoke. Oh, there it is. Oh, it's called the shadow, right? So yeah, it looks like it's baked. I definitely did not have wheels on because there's holes for wheels. But yeah, how did I manage to make it so smooth on the sides? I can't remember. Maybe I just had a different setup. Maybe I didn't use a. What if I make it lower? Yeah, let's maybe increase it. But yeah, you can. It's nice that you can preview with. Yeah, I should make the. So what happens if you put just tires inside? Is it going to be completely black? But yeah, the problem is that also, in the game, it's not perfectly. It's it really depends on where your car is, because if you jump off, right, you don't want to have a very sharp shadow. So you need to kind of balance it. You need to test different setups. Let's try this. Okay, now it's more square. I don't know, but you can at least see like the spoiler shadow or something, and there's a lot of noise. I think this one is actually a lot smaller. What's this? 128. No, it's actually the same dimensions, right? Oh no, this one is actually discard. Okay, you can make it when you discard. Oh, they changed the how textures work. Nice. You can actually change it live. Wow, this is super cool. Nice thing they actually added that in Blender. It's not that complicated as it used to be. So yeah, now I can even bake faster. There it is. It's already baked. Nice. But yeah, you can play around. You can add some volumetricness or something. Even that. Or I don't know, depending on what you want to do. Uh, hmm. But yeah, I feel like having a little bit of distance is actually nicer. So maybe I had a little bit of distance. That could have been it. What you can do also is that if you have like cloudy weather or something, you don't actually even need to use the sun. What you can do is you can just have the ambient light. So maybe that's what I did actually. If you go to the surface, where is the surface? Output, oh, that's in world. World, surface, there it is. So if you just use color, now it's more like, you know, it's coming from everywhere instead of just the sun. You could even use like a cloud texture, you could use a, you know, a skybox or something. This looks kind of nice. Let's try baking this. Okay, but still, it's still very dark. But now you can combine this with the sun, maybe. Something like this. Maybe. Yeah. Now there is some darkening on the sides as well, so that's nice. The cool thing is that if you have this, if you save this for one if you create this kind of a shadow rig, you can apply this to every car. So that's cool, because like you can just put a new vehicle inside and, you know, and create a new test rig. And the cool thing is that you can actually make this quad a specific dimension. So let's say I'm gonna use like 10 by 10 meters, right? So now I know that this texture is going to be 10 by 10 meters, and if I put it in the world, I know how, you know, I know how big the blob should be. Let's actually try this. Maybe I'm gonna, after all, I'm gonna put the wheels down a bit to just increase some. I want to increase the shadows, the shadows on the corners. That's what I want. And do I want to save this? Let's save this to another. Let's save this to spec 17.2. What node do I need? What do you need? What do you mean by what node? How are you going to expand on the map reader during races? Yeah, I have some idea, and I have code that I've written a long time ago for a sort of a map reading parser and player that I did for Infinland. So I think I'm just going to make that into C++. But for the first version, there's not going to be any code drivers, because that will take some time to make. Wait, I need a phone charger. I found things. What node? I don't know what node you're talking about. Okay. So let's try this actually in game, since I've gone so far. So yeah, let's bake this one again. 10 by 10. Let's add this into a shadow blob rig or something. And I'm gonna add that to a separate, let's call this a blob plane. Okay, so now I'm gonna bake this. There we go. I mean, it could technically be smaller, but I don't know. Maybe there's gonna be some affected pixels. And let's increase the, how do you call this? The sampling. Samples. Let's make it a lot more samples, so that we reduce the noise. Oh, nice, very smooth. Okay, so we have our blob, and we can save it as a not that. Save the texture, I meant. And that goes here. Save as Monty. Spec 17 blob. Shadow blob. RGB. Save. Okay, cool. So let's also save this and then I'm going to exit. And what I'm going to do now, I'm going to copy this one. Oh shit. I forgot that I should actually just probably make sure that the light, that I clip the whites, so that there's no so that the blob doesn't leak. I could probably have done that in Blender as well. with the compositor, but yeah, let's just move the levels so that it clips white, you know, so that we're sure that this is actually white. And the way you can test this is by having a making a new node here with levels and just making it super, yeah, like this. So we can see now that the brightest gray, let's say, is actually here. So it's not on the limit. And we could have actually done similar thing like this. We do a levels and then we do this. Oh, it's already not clipping. Is it? No, it's not. Oh, well, that's because I applied. Wait, I need to get it back. So yeah, if I create a new levels and yeah, you can see that the highest pixel is actually not white, right? It's not, how to explain this? Because you can also see here in the histogram, which is super tiny in the stream probably. So you can see that the brightest pixel in the image is not totally white. And we want it to be totally white because then we're going to see the gray shade in the texture, in the world, in the texture. So we need to guarantee that we push, yeah, we put it underneath. So wait, like this. So we guarantee that there is like the brightest pixel is white, something like this. There, you see that there's actually quite a bit of noise there. So at exactly this point, we guarantee that the edge is white. Okay, so we turn this off and we're gonna save this. I hope that was actually clear, the explanation. I don't know if that made any sense to you, but yeah. I know this from experience, so yeah, it's kind of difficult to explain. I don't need to save this. And so let's say that I copy this into my project. And so now we're going to use this spec shadow blob for our blob texture. Let's see, blob scale is 8.6. We're going to make it 10. Let's save this because the old one was like this. Okay, so it's 810. And we are going to replace this with the shadow blob, just so that we have the old one saved. And let's see how it happens. The bake in Blender 3.2 is the same. I think so. I have different items in bake. Yeah, I'm pretty sure it is. I am using 3.2, 3.2.1. It is the same. I mean, I don't know which one are you using. But I think bake didn't change much since 2.8. So anyway, yes, all this time I was just like what did I? Oh no, it's generating code? What is going on? Why is it baking the engine? Did I not compile? Oh, I probably did not compile. Okay, so we're waiting for the engine to compile. That's nice. Meanwhile, I can tell you about the input callbacks that I changed. So previously in my engine, you had to have annoying callbacks for your input. So you know how in Unity, if you want to detect a button being pressed, you just write if input.getKeyDown. This is exactly what I did. This is how I refactored yesterday my engine. But yeah, first let's see the blob. Okay, so here's the new blob. It's here. And it's perfect. I mean, it just fits perfectly because the scale is 10. And is it maybe upside down? Wait, I can't see anything in this darkness. Let's go somewhere where it's bright. You know, it would be cool to actually be able to toggle the lighting on and off. I just remembered. Wait, let me add this to my to-do. Nice. Also nice. Oh, come on. I can't drive. Oh. Okay, finally some nice lights. Okay. So, I think it's a bit offset from the wheels. And it could be the, oh no, it is correct because the rear side is actually smoother. Maybe it does fit perfectly. It's just that, oh no, you can see the shadow from the wheel, right? So it is good. It just seems a bit off to me, but that's probably because of the bake. I mean, you could just go into the texture now and expand it a bit. No window broken. Oh yeah. Well, there's no window. There's no windows at all. So there's nothing is broken. That's a life hack for you. Pro tip. Okay, let's drive up the mountain. It is a kind of low FPS. I think that's probably because of streaming. Oh, and yeah, actually, I was just thinking like maybe the shadows should not add, because if you're in a dark tunnel, it should still be dark. But the truth is that even if you're in a dark tunnel, there's still a shadow blob. Even in real life, there's a shadow blob in real life. Yes. You know, around things like ambient occlusion, right? Because things are still occluding lights coming from all the sides. So, but yeah, it looks good. I don't know if it's better than the old one though. It does feel a bit like it's floating in the air. Okay, anyway. That's it for that. We did manage to, well, there, have a little side mission of baking the blob. You can see that it's quite easy to do. Anyway, optional rendering. I did that. So yes, callbacks. I wanted to say that because back in the old days, from 2 days ago, new blob. Let's commit that and go back to removed input callbacks. Added early out. Okay, let's go here to this checkout and look at the code. So basically, what I had to do before is I had to tell to GLFW, which is a windowing library, you had to submit a callback for key events. So basically, you had to have a function like this, which you set into GLFW, and which gives you events. So you say, you know, you create a function like this. You need to create a function like this. You cannot make anything else. It's kind of like in C# if you know events. So like you need to submit an event. You need to, how do you say, subscribe an event with a delegate, and then delegate needs to have exactly the same signature, and then that event gets called by the engine or the library or whatever. So this is the thing that's called by GLFW. And then you need to check, okay, is this a press action? And then you switch on the key and you say, okay, if it's a if it's enter, change resolution, that's a key that I used to have, I don't have anymore. Or you say if it's C, then change the camera. So here's how I change the camera mode. Or you say if I press F, I unflip. So, you know, if I'm on the roof, I rotate the car. Or if I press the comma or the right square brackets, not the square bracket, the wedge bracket, how do you call it? The left one, I shift the gear lower, and then the right one, I shift the gear up. I upshift. And when I press escape, I teleport to the start location. So that's, and then I can also, with a backtick, I can toggle the UI. That's what I had to do. But the problem with this is that this function lives outside of the main code, right? So my main is actually somewhere over here, right? It's here. So it starts here. And then I do all the, I make all the parameters here, which are local to the function. And then I do the game loop. And the funny thing is that for inputs that happens every frame, if checking if something is pressed, I can do that easily with key pressed because it maps to a glfw function exactly. So I can do that easily. But now the problem is that my inputs are living in two different places. So one input is living, the input that is continuous, like if while the key is held, that is living in my game loop. And then the on, down, or up is living in a function outside of the main. So if I want to reference anything inside that, in that callback, in that function, basically what I have to do, where is it? Now I need to find it. Wait, it's on the top, right? Then I need to have variables that live outside of the main function, right? Where the hell is it? Switch. There it is. Okay. So yeah, it needs to, so all these parameters need to live outside of the main function. And so what I do is I have this struct called game, which are all in one in this struct. And then this is the stuff that you can actually change from key inputs, right? Like the camera mode. And that's a bit annoying, especially when you're developing, that you have to always remove these variables if you want one-time events. But now I actually added, now it works completely differently. So you can still optionally have subscribe to events like this. But now I have to completely refactor that and whoops, had detached. No, I should check out threaded leading, when I said leading. But it's wrong. So now this callback is gone. And what I have instead is very Unity-like, where I just say if key down, comma, do this, if key down, period, if key down C, change camera, if key down left control. So it's really easy to like go into the game loop and just say, okay, this is where all the inputs are. If I want, I have these continuous inputs while key is pressed. Yeah, do these stuff. But if I want immediate, I can just go if key down. And the only thing I have here is I put all of these into any key down, because this one tests if this is like a micro optimization, really. It just tests if any of the keys are down, and if they are, then I can test individual ones. And the way I implemented that is actually by having like for each event I push an event to a vector, which is in C++ peak is a list. So I put it in the list, and then I loop through that list and check if these keys are, and then of course after every frame, on every event poll, again, I just clear those events up so that they don't repeat, they don't propagate through frames, but on the beginning of each frame they're cleared, and then you can pull new events and get and find if keys are down, up, and which keys exactly. So that's nice. I really like that I refactored that. So that's it for updates since last time. Finally, after almost 2 hours of stream. No, well, 1 hour, one and a something of streaming. Any questions so far or something? Okay, so what I wanted to try to do on this stream is to try, well, I say garrote shading, but actually it's per vertex Lambert, because Bananaft also suggested that one. When I posted a video, which was kind of doing numbers on Twitter, right? I have more than 1,000 likes now on this on the thing that I did 2 days ago with the raycast, with the sun raycast, which is cool. Then Bananav said, okay, now you need to have per vertex Lambert shading. So I was like, okay, if I have a sun direction, I can really easily do that. So let's try actually doing that. That should be quick. So what I just need to do is I need to edit the shader of the car. Where is it? Where is it? Where is it? Where is it? Oh, this is the new blob. This is the old blob, and this is the new blob. So here's the difference. New blob, old blob, new blob. Yeah, the new one is a bit sharper. Anyway, so where is my shaders? Where are my shaders? Car shader. It's car shader, and then let's scroll up to the vertex, because I made this as I already mentioned before. I have this kind of packed shader file which I parse. I have both vertex and fragment in one file, which is kind of what they do in HLSL or in Unity as well. But in GLSL, it's usual to have vertex and fragment shaders in separate files, which is, yeah, I just didn't like it. I'm just so used to have vertex and fragments in the same one. Goodbye, Farfadet. Yeah, thanks for sharing. Yeah, no problem. The sun rises. The sun. Okay, so what do I do now? I need to have a uniform, which is going to be my interesting. I don't have uniforms here. I guess I need to add them. Include comments, yes. Uniform vec3, and we are going to have a sun direction. And now let's do a super simple Lambertian shading, which is a dot. Oh, right, I just remembered something. I can't actually do this because I don't have normals. I have no normals at all, so I can't actually do it. Okay, so yes, I'm actually going to not do it on this stream, or maybe for version 1 at all, because then I need to add normals, and yeah, I'm not going to do that. I don't need normals. So yes, that's okay. Well, change of plans for the stream. I'm sorry. I totally forgot that actually for Lambert shading you need normals as well, which I mean makes sense. But yeah, I don't have vertex normals. I only have position, UV, and color, and UV1, which I discarded. But yeah, for normals, then I need to import normals from the files and blah 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 blah. Not today. So let's go to the next one. The next problem I have. So I have finished this. shown this. So this is complete. Postponed. And lock the mouse and only move on right click or something. Well, yeah. Actually, I could do this a bit. I could try something. I could try playing with the camera a bit, because I want to improve it slightly. Maybe I'm gonna put it on a separate, in a separate class, because right now the way the camera works is that the engine yeah. Oh right, I totally forgot about this. I had to update it 4 times for it not to be choppy. Yeah, so the way it works now is that I just have an if, and else if, and else if. Like, if onboard, do this. If smooth follow, do this. If orbit camera, do this. But it would actually be nice to have it as a separate class or struct that I can reuse for other projects. So yeah, maybe I do that. Let's see what I have, what I need to have. Cargo, transform position, engine, camera forward. I definitely need to have the camera. What am I actually doing with the no clip controller? No clip controller? So I do actually pass it an engine, right? Yeah, I do. Right, I need to pass it an engine, and then the camera is from the engine. Yeah, let's make a new file. Amazing. Adds. New item. Don't you love the beautiful Visual Studio prompts? Orbit. Orbit cam controller, something like that. So I'm gonna call it the, is it the struct? Yeah, it is a struct. Maybe I should make it a class and then make everything public, because usually structs are just plain simple data. So let's do, yeah, can you see this? Is it big enough? Class orbit cam controller, and what I'm going to have is, should I write it like this? Or like, wow, this is so unusual to have them so big. I can look from space. Damn it, why do I keep missing the first hour of these streams? Yeah, when I was showing all the cool stuff. Now you've come to the boring stuff. Hello, Sir Bunkins. Oh, I think on the last stream you asked something really interesting on the end, and I didn't answer. I only saw the question later. So if you can, I can't remember what it was about. But I felt it was interesting. I think it was you. I did, super interesting. Now I don't remember it. Yeah. It was I don't know. It was something like, oh, I should have answered that. I will answer that on the next stream, and then I forgot about it. So yeah, what are we going to have in our beautiful no clip orbit controller? Let's have everything. So yes, one thing is we're going to have a reference to the engine. And unfortunately, that means that we need to have a constructor where we're going to assign the engine. How do you write it like this? I think I remember correctly. Like this, something like that. Alright, it doesn't know what the engine is, so I have to include the engine, which is going to include everything else. Yeah, you see, this is maybe not a very good idea, because if I include this, it's gonna include everything. Or maybe it's not. I'm not actually sure about these things. I need to ask somebody who knows C++ compilation more. How does it actually work if you include a header that includes other headers, but it doesn't have a CPP file? Oh yeah, well, I actually understand how it works, because what actually gets compiled is the CPP file. So if you only reference it in the main CPP file, you will not, that will be compiled. Yeah, so there's actually not going to be any extra headers included here, because I'm already including the engine. Check the video. I asked about tire friction and grip, but I think you answered that. You mentioned slip ratios. I also linked a video of my vehicle physics. You're right. Right. I saw the video of this little truck in the desert. I thought it was pretty cool. Like you said like it was a problem. That was, which I was like, wait, this actually looks pretty good. And you said like you wanted to make it more arcade, yeah, and not a simulation. And I was like, okay, so what's the problem? It looks amazing. So why exactly do you think it looks great to me? So we are going to have this thing, which I'm going to have a void update. Let's make it a new line. Okay, so there it is. We already know what our camera is. I can probably use like something like this instead. So that I don't need to have any of these. Just kind of nicer looking. Okay, compute access from view matrix, and then I need to have an object which is going to be positioned, but I'm not going to do that because I'm actually going to supply that as a parameter. Target. Target. Okay. So instead of having the position of the car, I'm going to have the target. I'm getting the camera forwards. And what is this? Camera distance. Right, I also have a camera distance parameter, which I'm going to add here. It's going to be a public float camera distance. So instead of using the game, I'm going to have the camera distance. And again, I'm going to look at the target. Okay, cool. So that should kind of work. So we've wrapped it inside a function. So instead of doing this, no shadow ray casts, no transmission. Yeah, I did not actually pragma region this. Pragma region transmission. And then I'm gonna end region here. And, oh yeah, pragma and region. So that I can collapse it. Do you understand what this is? Great, I did not want to collapse this. What is wrong? Why doesn't it work? Pragma region input. Pragma end region. Pragma end region. Pragma end region. Did I write it correctly? Do I need to say it again? Why doesn't it show me the... Oh, now it does. Okay, now you see. Okay, well, we fixed that. C++ is so bad. It's so slow with IntelliSense and with recognizing things and compiling compared to C#, I mean. Yes, so we have the camera, but before the is running, let's create the camera controller. So we have, let's bookmark this and come back to it later. In the game state, let's create, let's first include camera, cam control, orbit cam controller, and let's add to the game state, right? Orbit camera controller, orbit cam. Oh shit, we need to supply it with an engine. That's the problem also. So I can't do that here. That sucks with constructors because you need to supply them. You need to construct. Yeah. Oh, I hate it. I hate it so much. That's why it's so much easier to just use pointers. Hello, Marwy321. It looks cool, but it's actually a pain to control the steering. You can't tell from that camera angle. Once it starts drifting, it can be hard to regain. That's exactly the problem that I had in Infinland as well. And then, yeah, this is exactly why I want to make a super simple arcadey physics now. Because, well, the problem is really that there is so many things that can happen. There is so many parameters, and when the system becomes complex, once you change one thing, it changes 10 other things. So then you try to compensate with 10 other things, and then in the end you have a mess. So unless you really know everything about a car, about how about all the parameters, the suspension geometry, and you can simulate all that, then it's kind of easier. But if you don't have that, then you just kind of, yeah, it's just the number of parameters, because it's so many things that influences the way that you steer. It's the center of mass, like depending on what forces act on the wheels. If you lift the front wheels, you will have lower traction, so you won't be able to brake. You won't be able to steer, for example, and stuff like that. So if you sometimes you press on the gas, and then that depends on the suspension geometry, and that depends on other things. So yeah, you have just so many. It's so complex, and then everything influences everything else. Yeah. And then if you want to just I just want to make it feel in a certain way, and it's really hard to edit. Yeah, exactly that tweaking forever. Yeah, it was in Infinland I was just down the... But the thing is that I constantly feel no, that's not the problem with tweaking. It's the problem with my vehicle dynamics. So I have to program better, and then I try to add things into the code to make it better, but then it just makes it more complex, and I just add features which are, in the end, if I've probably just taken the first model I had, the first handling model I mean, and then just tweaked the values really well, I would have probably gotten somewhere, maybe, I don't know. But then I was just constantly thinking that no, it's not the tweaking, it's the model itself. So I added the model and then I go back to tweaking, and then everything I've tweaked so far is completely useless now. So I have to retweak everything, add new parameters, and yeah, it's just terrible. Yes, what was I doing? I was having the orbit cam controller, cam, orbit cam. Let's call it orbit cam, and let's supply it with an engine. So now, when we have here an orbit, when we have a camera, instead of calculate, where is my camera? Oh, well, here it is. So instead of this, I'm just gonna convert it to this orbitcam.update, and then I'm going to say cargo dot transform dot position, and that's it. So let's see if this actually works. So basically I wrapped all this code inside the orbit cam. And did I have some defaults for camera distance? What is this? Oh yes, camera distance is not initialized. Let's see what I used in here. Camera distance is 10, and I can also remove this because I don't need it. Well, this is going to be 10. So this probably fixes it, eh? This warning. Variable camera distance is uninitialized. Yes, but until Visual Studio wakes up and figures out that I've actually initialized it. So instead of this, so yes, let's assign it where I'm adding it, when I'm creating it. Where I'm creating it. Where I'm creating it. Such a mess. I should probably add it where the rest of the camera stuff is. And then say orbit cam dot camera distance. Well, actually it's baked. It's baked in. So what is this? What does it have? What does it say? Input. Yes. So the input doesn't work because I need to reference orbit cam. Okay. Let's see if that's... Why is it recompiling the engine? I didn't touch the engine at all. I created a new class, but it's not connected to anything else. It's including the engine, but the engine is not relative to that, so it should have just recompiled. What does NoClip have? So yeah, the cool thing is actually what I can do now is I can also add the update with default input, which I also did with NoClip, I think. Default update. Oh, I just called it default update. So yeah, default update. And what I can do here is I can use the engine and take the input and do my own... Well, good morning. So does the camera works? That's perfect. We're not clipping yet, but the wrap works. Okay. So instead of doing what I just did here, I'm going to move the orbit cam input inside the update itself. So so yeah, let's actually comment this, and I'm gonna use the same code over here. So yeah, the camera distance is going to change, and then I'm going to update by default. And then this update doesn't know that the update actually exists because C++, you need to forward declare things. Nope, that's not it. I just forgot to submit a target, which I don't have. What if I say update input? No, let's just have one function. It's going to wrap both default updates, and then I'm going to pass it a target. And the target doesn't change, so it can be const. And should it be a const reference? Maybe. It's a vector 3 after all, so... But why not be a const reference? Okay, so then we pass on the target. And the camera distance, yeah, changes. And also, I should update the position of the camera through mouse position, right? Right. Oh yeah, right. I have a mouse position. I should have a delta actually, and then adds. Interesting, but does it actually change? Get cursor position. Can you get cursor motion from GLFW instead of position? So the problem right now is that when you're moving the camera, if your mouse gets to the edge of the screen, it stops rotating. So I'm wondering if you can get motion, like leftward motion of the mouse, even if you're hitting the screen, the edge of the screen. GLFW mouse delta or something like that. That's how they call it in Unity, at least. Input guide. Cursor position. Okay, mouse input. Mouse input. Raw mouse motion. Yes, this is exactly. Raw mouse motion. Oh, if raw mouse motion supported. When a cursor is disabled, raw, unscaled, and unaccelerated mouse motion can be enabled if available. But only when it's disabled. Raw mouse motion is closer to the actual motion of the mouse across the surface. It is not affected by the scaling and acceleration applied to the motion of the desktop cursor. That processing is suitable for a cursor, while raw motion is better for controlling, for example, a 3D camera. Because of this, raw mouse motion is only provided when the cursor is disabled. I see, so the cursor needs to be disabled. Well, that's kind of a bummer. Call GLFW raw mouse motion supported. To check if the current machine provides raw motion. It said that, okay. So I guess you need to do this when initializing. Cursor object, custom cursors. I'm not going to have custom cursors yet. The stream is working fine. So let's go to input. And let's add a function. Wait a minute. Mouse position is a engine thing. I should move it to the input. This is going to be input. Input get mouse position. Okay. And I return a vector, which is kind of weird. Whoops. And yeah, let's add it to the... I learned that there's a shortcut to switch between CPP and H. Control K, Control O. So yeah, actually I'm gonna switch the signature. I'm gonna say... Okay, let's do this. Let's put the mouse region. Get mouse position and yeah, so without the input. Okay, and I need to reference the engine, which I don't have a reference of, but I have an instance. An instance of an app. Is it true? Oh, it needs to be a pointer. Okay, so I get this, I construct this, and I get a mouse position. Okay, but that's a real position, get cursor position. But what about a raw input, right? Raw mouse motion supported. When a cursor to say raw unscaled mouse can be enabled if available. Okay. But how do you get the motion? To check if the current machine provides raw mouse motion input mode to enable it. It is disabled by default. Okay, so I guess I'm gonna add another one, which is gonna be enable raw mouse motion. Enabled. Something like this. Or set raw mouse motion. No, enable. Maybe better wording? I don't know. Let's add this here. Or we can also kind of try, let's see if that actually works. Automatically create a definition, sorry. Okay, that sort of worked. And then we're gonna add these things. So let's try. And then how do you get the raw motion? It doesn't even say how do you get it. Set input mode, cursor hidden, okay. Cursor position. And when it moves over the window, set a position callback. The full subpixel cursor position is passed on. Interesting. The cursor position is also saved per window. Ah. Interesting. You should not implement your own version of this functionality using other features of GLFW. Okay. So yeah, for now, but maybe I want a function that is a delta as well. Get mouse delta. Get mouse motion delta. So this is going to add This is going to get us like the motion from the last frame, right? And the way I'm going to do this is I'm going to add a new parameter here, where I'm going to save the mouse position, last mouse position. Okay, so here I'm going to return a last mouse position. So get mouse position, it's going to be a vec2, right? And then, yeah, position, last minus position, I think so. Let's just use autos, like real people. And then here I'm going to set a new position. So last mouse position is, oh no. No. I'm actually going to I'm gonna set the new position at the beginning of the callback over here. No, not the input, not the init, but in the where is my poll events? Here. So I'm going to say position mouse last mouse position is get mouse position. So yeah, at the beginning, so this is called at the beginning of each frame. On each frame I reset the position to the one from the previous frame. And then what I'm going to do is, yeah, the delta is then the difference. And I'm going to just return that delta. Right. So the get mouse position, this is actually a const, isn't it? Well, this is not a const. Let's see if I can make it a const. Whoops. Let's see if that compiles. And then the delta can be const as well. Lock mouse definitely changes the state. Get scroll wheel delta, that should be a const as well. Yeah, because it just returns a scroll delta. Enable raw mouse motion. Well, this one changes the state of application. I guess I'm not going to. Oh yeah, this one also doesn't change anything. Oh wow, I totally forgot that this one actually doesn't. So yeah, because I'm reading off a key down, I can just make all these functions const. Well, I should be able to anyway. Let's see if it works. Yeah, it does kind of compile. And then this key could be const as well, but it's not really necessary. But yeah, for the vector2. Okay, so I have the delta. Let's try to read off the mouse delta for the beginning. So GLM, no, vec2 mouse delta. What am I doing here? I want to do spid log info, and then have this thing, and say get mouse move. No, engine input get mouse motion delta. But I do need to put it in a variable. Something like this. Let's try to compile. Oh! Yes, beautiful. Oh my god, I love link errors. This is the best thing ever. Okay, what does it say? Probably can't be const, right? Orbit cam controller. Unresolved external symbol. This get mouse motion void. Oh my god, these messages, they're so terrible. The output is actually giving me a bigger text, at least. So this compiled correctly, but then the N-engine drive did not. Oh wow, there's so many errors. Yeah, so what does it say? This call blah 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 blah. This call, what? Unresolved. Okay, unresolved symbol means that I did not write the signatures correctly or something. Oh shit. Oh no. It's okay. So let's see. What was the problem? What was the issue? Get mouse position void. Get mouse position void. Is the signature exactly the same? Get mouse position void. It returns a vector2. Maybe the problem is that it's a const. Vec2 get mouse position const. Let's remove the const. Oh, now I need to remove this const as well. Yeah, this is why I usually do the constness on the end. No, not the mouse delta, but the... Oh shit, wait! Wait a minute. Get mouse position. Oh no, this is correct. Sorry. Mouse position, mouse delta. Let's see if it builds. If it doesn't, then something else is a problem. Okay, great. Something else must be a problem. What does it say? This call, get mouse position. What the hell is this? It's like... Okay. I need to like look it into separate, like... What is this error? Please. Please. Please, Microsoft. Unresolved external symbol. Struct. GLM. Vector float. I have to do it like separate thing, like so that I can see anything. Get mouse position. Referenced in function. This call. Orbit cam controller. Update. Oh, the problem is the updates. Okay, wait. So I think that this is not the problem. The problem is actually in the orbit cam controller. Are you missing an include for it? Maybe I am, yes. So where is it? Here is the problem. Default updates. Get scroll wheel delta. Is it the scroll wheel delta? No, it's once a mouse position. References function. Updates. But I am including engine, which does include input. Wait a minute. Oh, well, this is the problem. I removed the get mouse position. And the signature, the declaration stayed. Yes, I moved it to input. So actually I should remove this. This is it. Damn, I totally... Yeah, this is what I hate about having to maintain both the headers and the CPP files. When you need to move things around, you forget things. Maybe I have some other garbage. But yeah, I mean, it was kind of greened out, which says like, oh, I can't find declaration. But like, yeah, I know. This was the problem. So basically I need to change from engine to a... And now there should be an error because this doesn't exist. Because not even the header, the declaration doesn't exist. So instead I need to do input get mouse position because I moved it there. Okay, let's see. So yes, it was not an include problem, but it was a problem with that there was a remaining declaration which I didn't remove, and then that declaration, but the implementation I removed. So yeah, that's a typical linking problem when it can't find an implementation. The worst is when you're trying to integrate a library into your project or something, and then you have beautiful linking errors when you can't figure out why why doesn't it include a static library or a dynamic library or something. Okay, so there it is. And mouse delta is 0, as you can see here in my beautiful log. If I move to the left, I get positive numbers? Wait, it should be the opposite, right? If I move up, okay, so I did the wrong math. I suck at math. So yes, if I shut this down, oops. So I move up, I move down, I move left, I move right, and now I shut down. And you can see this. So this is probably the yeah, well, I don't know which motion that was. But for sure, I saw that the minuses were opposite. So I should definitely flip it around. Flip it around. So it's not the delta. Where the hell is the delta? There it is. So it should be position minus last position instead of the opposite. Okay, so now I can pass this actually to the all right, the set input rotation. Right, I'm actually directly setting the rotation of y and x. Of y and x. And the thing is that I should make sure that these y's and x's don't cross the limits. But yeah, what I need to do is I need to now just add. So yes, let's have a GLM vector 2, which is going to be my pitch and yaw of the camera. Let's call it a direction. Oh yeah, I'm calling it a distance, but I don't need to call it camera distance. Just okay. Let's call it camera direction or something like that. Camera rotation. This, I guess. Okay, and we're gonna start with 0.0, right? And then with my default update, I'm actually going to add the delta to that. Camera rotation plus equals engine input delta by 0.005, because that's what I have. I should also have a mouse sensitivity. Parameter. So now it's actually static, but I should probably multiply it with the should I? I should multiply with delta time. That's what I wanted to say. I didn't finish the sentence. So yeah, maybe, I don't know, like this. Or should I make this the sensitivity? Yeah, maybe that's... No, let's make it 1 for now. And now let's make it this. Okay, so my mouse sensitivity is 0.00. Oh yeah, and I should actually add that here, not up there. So now I'm going to set the input rotation to a camera rotation instead. Right, because this is not the delta. This is the absolute rotation. I think so. Yeah, this should be the absolute rotation. So yeah, let's see how this works, if it's the same thing or a different thing. Oh, am I default updating it? Did I forget? What is this? Byte flag. Oh, this is another project. Byte flag. Oh yes, orbit cam. I'm not default updating it. So yeah, it won't move. The camera won't move. I forgot. As you can see, the camera is not moving. It's just constantly static. Which is a good test, actually. So, but we're gonna have a default update instead. So now it should move. Okay, so let's see. Oh, it's much slower than before. That's weird. That's interesting. Okay, that's really interesting. Like the delta is not consistent. So yeah, that's probably because I'm not using the raw mouse motion. But it's interesting that, right, if I hide it, then it's much... If I hide the mouse, it is actually... Oh, I need to flip the mouse wheel as well. Oh, and you can totally flip the distance. It's not clamped. Okay, let's actually add a minimal distance as well. Float min distance is going to be a, let's say 1 meter, and then float max distance is going to be, I don't know, 100 or something like that. Minimal distance is going to be, so yeah, let's clamp the distance. Camera distance is clamp. 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 I think I have this here. Clamp. Come on. No. No IntelliSense. Okay, I need to remember how to use it. Distance. Camera distance. Min distance. Max distance. Okay, so the camera distance never crosses that. And what I want is, I want to clamp the rotation as well. So camera rotation is anti-K clamp. Now let's do it separately. X anti-K clamp. So should I clamp? I think I need to clamp the Y. And I want to flip the Y bool flip y-axis. You always need this because people are going to complain about the y-axis all the time. That's what people always do. So if I have a mouse delta, let's see, mouse delta is mouse delta y is minus mouse delta y, but if not flip rotation, flip y axis, then flip, okay, we can put it like that. Okay, and then we are going to add the delta, and we're going to clamp the y to camera rotation y from minus pi. Yeah, it's a template, to plus pi. Okay, let's also add this half pi, 90 degrees, limit, let's just call it a limit, is GLM pi float by 0.5, Constacks per float. Okay, and yeah, let's do this. So now I think so half pi is 90 degrees. That's why I'm saying it. So I think the camera rotation is hopefully going to be limited when you're looking up and down. And we look down. Oh, we can't look down. Okay, now we can. And the everything disappears for some reason when we hit 90 degrees. What the hell? What the hell? Okay, interesting. So I think there's some... I think the problem is with the, you know, because I'm trying to look at up with an up vector. And then that means that the matrix becomes invalid. So the camera matrix becomes gibberish, basically. That's what happens at 90 degrees. This is so funny. Yeah. So the way to fix it, the way you fix this problem is by not having a 0.5, but instead having a 0.499. So now we should clamp it to like just next to 90 degrees, but not quite 90 degrees. So that's let's see. Yeah, as you can see, we've fixed this issue. This is how you fix issues as a real programmer, as a chat programmer. Cool. Oh, and we need to invert the mouse wheel as well, because I'm scrolling out to scroll in. Get scroll. I'm gonna say minus equals. So yeah, everything works great, and I can zoom in, and it also limits, and I can add my own limit. You know, another thing that would be cool is to add some smoothing, and also have some exponential, like looking around, but that's a bit too much. I don't know. No, let's do that. Okay, well, I'm doing this all the way, so yeah, let's try that. Oh, by the way, this is 10th stream. So yes, it's 10th stream, and there's 10 viewers right now, so that must mean something. On the next stream there's going to be 11 viewers. Let's add some smoothing, right? Because why not? Let me actually commit this and say nice. Oh shit, I have the engine as well. Added mouse delta. Added mouse delta functions to input. And position functions to input. So I'm gonna commit this, and then I'm gonna commit everything else. Separated orbit cam from the rest, from the game, from drive. That's the code name in the code base. Yeah, so current distance. Oh, I have camera distance, of course. But what we can do is we can have a camera distance float camera distance smoothing factor, which is going to be a 1 for now. And instead of mouse scroll directly influencing the distance, what we're going to have is we're going to have a target distance. So camera target distance. And it should be the same value. So now what we do is we change the target distance, and the actual distance is going to be smoothed. So let's try just lerping. No, let's try smooth damping. And now I need to see what are the parameters, because IntelliSense doesn't work for some reason. Current target velocity. So current is camera distance. Target is camera target distance. Velocity. Oh, now it has decided to work. Current velocity is, let's move it here, is, well, we don't have it yet. Camera distance velocity. Camera distance velocity. And maximum speed, smooth time is going to be smoothing factor. And the smoothing factor, and let's make it smaller, because I think it's going to be probably too smooth if it's 1. Oh, delta time as well. Engine delta time. Maximum speed. We don't need maximum speed. Okay, so that's it. That's going to be the camera distance. So now it should be smoother. Let's test it. And, oh my god, look at this smoothness. So smooth. I scroll in. Yeah, this is now too smooth. Let's not make it that smooth. Let's make it faster. 0.1. Okay, much better. Okay, so now we have the smoothness. And you know what? There's one more thing I want to add, and that's when the camera goes far, I want to make it exponentially go faster. So the change should not be linear. It should, the closer you are, should be smaller increment, because right now you scroll once, it goes back by a meter. Like you always go by meter, but I want to make it when you're close, it should be much slower and then much faster in the distance. That's, you know, that's a nice trick, and it's always nice to have that. So the way I'm gonna implement that is that I need to use an exponent, which, you know what, I'm actually going to cheat, and I'm going to look into my... Oh look, there's 1.3 gigabytes left. Nice. Okay, I'm actually going to look into my Catamaran Cats project, which is this, because I have implemented the orbit cam there as well. So let's see, orbit camera controller. Let's see how I did the distance. Camera distance. Okay. Distance is scroll speed. Wait. Where am I actually calculate? Maybe this is the old one without the exponent. This must be the old one. Oh, there's another one, orbit cam. Yep, this is the one. I'm getting a scroll and distance input. Scroll by scroll speed. Okay. Yeah, I should also add a scroll speed. Floats scroll speed. Maybe 1. Let's see, what does it say? Okay, so you're multiplying the distance input, right? I have a separate thing which is called an input, and then a target, which is a power of distance input, and POV, which in my case is hard-coded. Okay, to 3. So let's try that. Floats. Oh. Distance, camera distance power. Let's also make it 3. And yeah, so the distance input, there's 2 things. There's a distance input and there is an actual distance, right? So what I'm doing with the scroll is I am I'm influencing the input itself, which should probably be 0. I don't know, at the start. Is it 0? Distance input. It is 0, I think. So yes, because the distance input goes from like plus to negative. So what I'm doing here is clamping distance input. Am I? But how do I know how to clamp? Distance, minimum input distance. Oh, I am actually calculating the powers of these. Okay, well, interesting. And I'm doing this on the fly. Minimum, let's put minimum first. So do I have a power somewhere? POV. Yeah, it is a... It is a C function. So I hope it works on other platforms as well. Oh, distance minimum versus distance maximum, distance versus distance maximum. camera distance power. Okay, so this calculates minimum and maximum distance in power space, so to speak, so that I know that this is going to be the I need to clamp between these inputs. And then what I do is the actual target distance is the power of distance input and input distance. Oh, this should be the input, not the target. Distance inputs. Distance input and the camera distance power. And so if everything is correct, this should be it. If the power POV F actually works. Okay, let's test. Oh, well, it does work, but the power is very strong. Whoa, yeah. So it is slower when you come to the car, and then it becomes 0. So there's something wrong with clamping. Am I not clamping correctly or something? Minimum distance and maximum distance. Interesting. Okay. Minus. Oh, I'm also minusing here. Minus by distance scroll speed. Wait, where is my camera distance velocity? I should probably add that here. Oh no. Scroll wheel delta. Distance velocity. Oh, this is a smoothing velocity. Oh, scroll speed. That's the one. That's the one. Which I forgot to add. So let's make this like 0, 1. But I'm still perplexed why the min distance doesn't work. Distance inputs. Scroll wheel, and it should clamp between these two. Target distance is power of distance and camera power. Distance is smooth damp of distance. Target distance. Distance. Am I actually smoothing before or after input? Oh no, I'm actually smoothing after input. Interesting. Okay, so for some reason. Oh wait, well, but this is the minimum actual minimum. So it's correct. It is correct. The problem is that my minimum is too minimal. So instead of 1 meter, let's make it 2.5 by default. I don't know. 2.5. So of course I can change this in the engine as well. Any of these parameters. Sorry, not in the engine, but in the drive. Yeah, so this is a better minimum. Okay, and yeah, it does scale up and then scales down. It's much slower. So perfect. Okay, I did it. So when it goes far, it becomes much easier to scroll. Nice, and it's very smooth. I don't know if I should have like Oh, it's interesting that it actually becomes much faster when you hide the mouse. The delta. Anyway, it's cool that this works. Okay. One more thing that I wanted to add. Camera, scroll speed, minimum distance, mouse sensitivity. Right, the limits are hard-coded right now, but should I have them not hard-coded? Maybe. Smooth orbit cam. That's cool. So yeah, how do you actually get mouse input? GLFW mouse button inputs. Mouse buttons. Let's see. For how these are used. GLF sets mouse button callback. Okay, so of course there's a callback. There's another callback. Okay, the funny thing is I don't even have mouse buttons. I only have keyboard input so far for the past 2 years. It's the first time I'm going to implement callbacks for the mouse. So static void glfw mouse, what's the name? Mouse button callback glfw window, and all the parameters are going to be button action mods. That's the parameters. Button action mods. But of course, it's a function pointer. It needs to have parameters like this. Oh wait, I mean this is not a. This is weird. I didn't know this is allowed. Like, to have no names for parameters. That's strange. Maybe that's a C thing. Why? Oh, because I wrote it incorrectly. Okay, so let's create this definition and go to the C++. So for the mouse buttons, I also need to have buttons and actions. So let's add another vector, I guess, for events, for special mouse events. Button action mods. So now we have to reserve some well, there's not going to be so many clicks, so let's say 8. Mouse button. Mouse events. Yeah, mouse events, and then I'm gonna push mouse events into the callback. Mouse events. Oops, mouse. Oh yeah, I need to get access to the input first. Mouse events pushback. So the key is going to be the button. The scan code is going to be 0, and then action, and then mods. And what I'm going to do here is yes, now I need to have the special bool input key pressed mouse button down. No, int key const, and this is going to be a button. Create declaration. I'm gonna move it to the mouse. Thank you. So basically I need to say, okay, for each E in mouse events, I check if the action is glf press. I think so. Press release. Oh, it's funny that press release, I never realized that. When you say, you know, like in journalism, press release, it's like two opposite words when you say that. Because you press and you release a button. That's funny. Never realized that. Okay. Random worldy things. Let's go back to the engine world. So yeah, if key is key, if button is button, return true. So it's kind of simple. And I'm also going to do one with up, where the glfw is going to be glfw release, and yeah, basically the same thing. And we're going to add a declaration. So that should be it. And then at the beginning of the frame, I also need to clear mouse events. Okay, nice. And I think once I finish this, I'm going to end the stream. Orbit camera. What did I want? I wanted to click. I wanted to try a click. So let's just try here in the input. If engine input gets mouse button down, and the button is, oh, there is actually a left Mouse button left maps to 1. Okay, so you can actually use a GLF W mouse button left game SPD log info pressed. Yeah, let's remove the delta. Pressed LMB, and then we're gonna see an arrow RMB with the right. So hopefully this works. But why did I want to implement this? Because I wanted to rotate the camera only when you press right. Possible loss of data. Right, we need to static cast this to float. Okay. So, when I click, oh, there's something wrong. Oh, there's something wrong. Oh, there's something wrong. Okay, what am I doing? What am I doing wrong? If the key is pressed. Oh wait, I'm actually pushing back all the time. Right, but I should be pushing back. Upgrade cow. So, mouse events. If action is press and key is button. Oh, I don't have a return for false. What the fuck? I hate C++. I hate how it doesn't tell you anything about return not even existing for another case. How is that possible? How was there no warning or anything? Maybe there was, I just didn't see it. Oh, there's 500 warnings. Asset manager. Well, texture. Yeah, who's gonna find these? Yeah, this is what sucks about warnings. There's so many of them that uninitialize always init variable. Yeah. Yeah, this is one of those terrible things that you cannot catch. So yeah, let's see if this fixed it. So yeah. But if I click, nothing happens now. So that's not good. That's not good at all. That's not good. Mouse events. Oh, I forgot to submit a callback. That's the problem. Mouse button callback. glfw set mouse button callback, and of course app window, and then we have input and this. Okay. There it is. Pressed left mouse button, pressed right mouse button. Perfect. Okay, they finally work. And I also want to have a while a mouse is pressed. Is there a way to do it? Mouse button states for named buttons are also saved in per Windows state arrays that can be pulled with glfw get mouse button. Yes, so you can do that as well. Let's add it too. Like this. Create definition. Perfect. We're gonna move there. We say mouse button pressed. App window button, and if state is upgrade cow, well, we're gonna have return true, or we can just say return state is press. So let's try that in our engine, just to output. If engine input mouse button pressed, let's try it with the left button. glfw mouse button left. SPD log info mouse button being pressed. Hello, Pirxos, nice to see you. I was about to kind of slowly wind down the stream, but yeah, I'm right now making this orbit camera work, and also I'm adding. I didn't, all this time, I didn't have left and right mouse button at all in my engine, so I'm adding that now. Mouse buttons at all. I just use keyboard, which is funny. Somehow the mouse buttons work in with the GUI, so I could have moved this, but I couldn't. Oh, mouse being pressed. Nice, there was no up. Oh yeah, I'm not actually detecting a release. So yeah, let's see. Click being pressed. Nice. And there's only one click. Yes, there is. Okay, perfect. And the right click is only pressed. So now I have clicks as I should have. And yeah, the orbit camera is now very smooth and works well. And it has exponential distance, so the more distant you are, the faster it moves. So when you're close, you move slowly, and when you're far, you move faster. But the reason why I wanted to have left and right mouse button is so that I only can rotate when I'm holding a mouse button instead of rotating all the time. So because it's really annoying when you're manipulating the GUI and it's constantly being used. So now I can finally say that added mouse button support in input. I can finally say that this works, and I can very easily log a, let's get an input from the mouse. So I say mouse button pressed. The button is glfw mouse button right. I'm gonna use the right mouse button. So while it is pressed, I'm gonna update the orbit cam. If it's not, I'm not. Oh shit! I actually think I need to update the input, update the camera, but not the input, because it's not gonna move. Right, I didn't think about that. So I do need to split the. Oh yeah. This is funny. Okay, so I can update the movement. So it does work as intended, but the problem is that once you release the mouse, the camera is not even following anymore. So if I'm not pressing the button, it just... It's kind of funny. Some nice shots, but this is now... Oh shit! Now I want to make like Resident Evil, but rally game. A driving game with Resident Evil. Man, that's untapped potential right there. I should not be giving out ideas so easily on stream. Well, that's nice. That's a Resident Evil shot right there. Look at that. I wanted to drift, but I failed completely. Ah. Nice. Yeah, Resident Evil driving is hard. The sound, there's no sound volume, so yeah. Okay. I mean the positional sound, there is no positional sound. Look at that. Oh my god. Ah, almost. I'm not very good with driving it. Oh, there it is. There's the drift. There is the crash cam. Let's go to the mountain and have some better views. Oh shit, I can't even go to the mountain anymore because there's a wall everywhere. I totally forgot. Okay, there is an access. It should be a two-player game. One drives, the other shoots. We played an arcade like that with my brother. It was about killing dinosaurs. Okay. Okay, now this. No. No, here. Here is the best view. Oh yeah. Damn, wait. Ah! Come back. Come back! Now it's gonna fly away. Okay, here. No, one more. Here. Ugh, I can't position the camera. I suck at being a cameraman. There we go. Let's turn off the frame buffer. Okay, now adrift. Oh, almost. Oh shit, too much rotation. Well, nice. I hate it. Ah, I can't go uphill. I can't start going uphill. It's a problem with my tire model. I need to improve it. And now I can't. Yeah, it's super hard to turn in this. Okay, here we go. Nope, terrible. I'm really bad at driving like this. Okay, well, that was a try. But I'm done with that now. Okay, so what were we doing here? I totally forgot before the Resident Evil camera. Right, I was updating, but I need to split inputs from camera updates. So yeah, this is going to be the default input updates. And I'm not going to give it a target. After all, I think so. But instead, I'm going to remove the update and have only the default input updates, and then I'll do the orbit cam updates, and then I'm going to update the cargo transform position and remove this one. So now the input update is completely separate from the camera updates. So now when I use the orbit camera, oh, it still doesn't work. Because the yeah, because the update also needs to calculate the inputs and everything. Right. Camera target distance. Rotation, right, I need to calculate the rotation as well. Mouse delta. Camera rotation. Right, I'm going to do this. So I'm going to have what is all the parts that are input. So this limit rotation is part of the input. I distance input it, I clamp the distance, and then this is what should be in the update. So this should be part of the update. And the mouse delta is part of the input. The rotation gets added to that. So this is going to be part of the update. I think that is it. So I completely split input from the camera update. So technically you can also supply your own input if you don't want to do the default input. Oh. Oh, it's called totally broken. Okay, so what am I doing now? What am I doing now? I distance input. Oh, because I'm not running one. Okay, so I actually need to run it once so that the distance input is clamped. So at the beginning, I'm going to clamp. I need to make the distance clamp at the beginning. That's the main thing. I should probably add that to a separate function. And then I'm going to finish the stream. So yeah. But this should be outside, really. So in the beginning, I'm just going to clamp input distance. No, this should be a capital. So, okay. There we go. Cool. It works now. So that's great. I think this is exactly what I wanted to do. I think I'm going to end the stream here. Wow! I didn't know this was possible. Wait a minute. How does this happen? Why doesn't the car just... Why does the car stick? Well, I can't repeat it now. Okay, the cool thing is that the camera works. I didn't do much as I intended. What are the things that I did do? Lock the mouse and only move on the right click or something. Yeah, that actually works, but I didn't add... And getting triangles from the ground, that's what I did not do. So, yeah, next time. Stream. I'm gonna add that for future ideas. To make, how do you call them? The guardrails. Guardrails. Okay, cool. So, thanks for watching the stream again. Once again. And I guess I see you some other day. Definitely not tomorrow. Maybe Saturday. Maybe Sunday. I don't know. But either Saturday or Sunday I think I'm going to stream again. Tomorrow I got a lot of work to do. Other stuff, not engine stuff. So I'm kind of ending here. Well, productive stream. Yeah. I mean... I wasn't really planning to do this orbit cam, but you know, since I was like, okay, I need to fix these things. So yeah, I also want to add like a no clip camera that I already have, which is like just a free flying camera. And I think I'm going to add some. I have it in some other projects. But here I don't in the car, so I think I'm gonna add one more camera. I might do that off stream, I don't know. So yeah, I have a feeling that the camera stuff is a bit boring. Oh, and the thing is that I want to add some smoothing to the in-car camera, vertical smoothing, so it feels more like a gimbal instead of just being fixed straight to the car. I might do that on the next stream. So... Because that's the interesting things, vector math. Make the in-car camera behave more like a gimbal. Okay, cool. It needs a drone cam that follows you dynamically. Yes, I mean that's that's the dream. I kind of had this a thing in Finland. I had like a helicopter that was, but it was like fixed. It wasn't really dynamically flying like real. It didn't use like real physics, but it was kind of smoothly following from a distance. It's basically like the orbit cam. It's basically the normal camera, just with a. It's this camera. Wait, I don't need to have debugging. I'm just gonna start it from here. So yeah, what I actually had was kind of like a normal camera, because this camera, this smooth following camera, you can actually make it, wait, where is my thing? Car data, it's in car data. No way. Oh, there it is, it's camera on the bottom. So yeah, you can actually change the position. You can say smooth follow distance. Yeah, so I can change the distance, and I can change the up. So I can make my, and then Wait, where? Let's remove the frame buffer. And what I can do is I can also... What is the rate thing? I'm not sure exactly. Oh, okay. So the rate is actually how smoothly it follows. So yeah, if you reduce the smoothness, if you make it even smoother or like laggier, now it feels like a helicopter. You know, it's kind of trying to follow you, but wait. Yeah, let's make it a bit faster. Oh, there it is. So now it's like watching you. Imagine the sounds. So yeah, you can say that there's already a helicopter cam in the game. I just need to make it like a separate camera thing. But then also, I mean, it's not supposed to follow you exactly behind. Look at that. Oh, it really works well. This is kind of what I had in Infinite actually. It was kind of flying on the side on the side though. Oh, crash. There it is. Crash on the camera. So okay. That's yeah. It does look good. That's pretty much it. And you can see the smooth shadows now from this perspective. So yeah, basically what I need to just make it, I need to make the helicopter not collide with the ground. And I mean, it's not that difficult to make it fly realistically, like with a PID controller or something, to make it really like a drone. But now it's going to go through a mountain. So obviously that's not what helicopters do. I mean, they try, but they try going through mountains, but they don't really ever get up again. Okay. Ooh. A bridge shot. Okay, so that's it for this stream. Yeah, it needs to focus on somewhere between the car and ahead of you along the track. Yeah. Yeah, I mean, it's like when you think about framing, it's always nicer to have some space in front. I mean, you can add like the velocity of the car. Just say instead of targeting the car exactly, make it target the position of the car plus a bit of velocity, like 10 meters in front, depending on the speed of the car. So yeah, you can fiddle with that around. I did that for Infinite as well. Cool. So yeah. Doesn't work well for hairpins. Yeah, it doesn't. I mean, ideally, maybe you need to have some kind of like preset points where the camera, where the helicopter is gonna look at. Like, oh, you're approaching a hair point. Look at the hairpin instead of the car, or something like that. But then it needs some kind of authoring of the triggers and everything. So that's more work for the track designer, who needs to also put... Also, I mean, I would love to have static cameras when you play replays, you know, and you have static cameras on the side. I mean, trackside cameras. That's what I mean. They could be following you, but then you need to make this whole system about like detecting when you enter zones of cameras and stuff. But it would be cool. Okay. So, that's kind of it for today. Yeah. Nice making some camera stuff. See you next time, Saturday or Sunday. Good night.